property of multiplication. We take in two integers, minus 2 and minus 1. Two integers. Let's multiply these two integers. Integer 1 and integer 2. When we multiply these two, we are getting plus 2. So plus 2 is also integer. So when we multiply two integers, we are getting the result of an integer. So the closure property of multiplication, over integers is applicable. Let's take some other example. That is minus 3 into 5. So minus 3 into 5 is minus 15. So we have taken two integers and multiplied. We got an integer. Minus 15 is also an integer. So the closure property of multiplication over integers is applicable. So let's go to the next concept, that is commutative property. Commutative property of multiplication over integers. We know that we have learned in previous class about the commutative property. That is, take two integers and we change their places. Minus 1 into minus 2. Then we need to get the same result on both the sides. Then we say that commutative property of multiplication over integers is applicable. So let's see on both the sides. Minus 2 into minus 1 is plus 2. And also minus 1 into minus 2 is also plus 2. Plus 2 and plus 2, both the sides are equal. So we can say that closure property is under multiplication over integers is applicable. So let's take some other example. Minus 3 into minus 2. Minus 2 into minus 3. So 3 2s are 6. Minus into minus plus 6. And this is also plus 6. Both the sides are equal. So closure property of multiplication over integers is applicable. Let's go to the next concept, that is associative property of multiplication. Let's take an example. Minus 3 into minus 2 into minus 1. That is equals to minus 3 into minus 2 into minus 1. So let's simplify this. So minus 3 we have written same as it is into minus 2 into minus 1. So we need to multiply, which are in the brackets using the Bode-Marx rule. So let's multiply this 2. We get plus 2 because minus into minus is plus. So plus 2. So let's simplify, which is in the bracket. Minus 2 into minus 2 is plus 6. So plus 6 into minus 1. Let's simplify both the sides. So left hand side, minus 3 into plus 2 is minus 6. Plus 6 into minus 1 is also minus 6. So minus 6 is equals to minus 6. Both the sides became equal. So we can say that associative property of multiplication over integers is applicable. So let's go to the next concept. Multiplicative identity. We have taken any number, any integer, and multiplied it with one constant number. We need to get what we have taken, the number. So the number with the result is except what we have taken. So let's see what is that number. Minus 3. We have taken an integer. We need to multiply a constant number. We need to get the same result. So to get the same result, let's see, it is not possible with any number except 1 because minus 3 into 1 is minus 3. So if we take 0, minus 3 into 0 is 0 we get. Minus 3 into 2 is minus 6. So except 1 we will be getting the different values and will not get what we have taken. So for 1 we multiply with 1 we will be getting the same result what we have taken. So let's see for some other example. Minus 2 into minus 1. Sorry, minus 2 into 1 is minus 2. So minus 5 into 1 is minus 5. So 3 into 1 is also 3. So what we understood, what we have taken number any integer multiplied with 1 will be the same result of what we have taken. So this is called multiplicative identity. Multiplicative identity. So let's go to the next concept, that is distributive property. Distributive property. So if we have taken a number, an integer, over multiplication, -1 plus -3. So we need to distribute this -3, no, -1 and -3. Like -3 should be multiplied with -1 and -3 is multiplied with -2. So -3. So we need to get the same result which on the right hand side also. So what, let's simplify. So -3 into -1. We have distributed this -3 and over -1, and now we need to distribute this -3 to -3 also. -3 into -3. And between these two integers there is a addition symbol, so take the addition symbol. Let's recall, we have learned distributive property in previous class, that is a number and one of the number should be distributed, and which two other values or three values, we call it as a distributive property. Here -3 is distributed from -1 and -3, and like -3 into -1 we have taken, and -3 into -3. So this -3 is distributed among -3, -3, sorry, -1 and -3. So let's see both the sides we get the same result or not. -3 plus -3 into. So let's simplify these two values, that is -1, -3, that is -4. And here on this side, -3 into -1 is minus into minus plus 3. So plus -3 into minus is 9 plus 9. So when we simplify, plus 3 and plus 9, we get 12. It's plus 12. 12 we got, and minus into minus is plus. So we get 1 plus here. So 3 4s are 12. So on both the sides we will get the same result, plus 12 and plus 12. So this is called distributive property. So one of the number is distributed among two or more values. So we will tell that is a distributive property. Distributive property of multiplication. This is multiplication over addition. Also we can do multiplication over subtraction. So multiplication over subtraction, that is distributive property, is applicable for integers. So let's go to the next concept. These properties of division. Properties of integers under division. Let's see. First property, division property under division. Let's take any two integers. -3 divided by -2. So when we divide these two integers, we'll be getting result. The decimal places, it was -3 divided by -2. We know that minus divided by minus, we get a plus. So plus 3/2. So when we divide these two numbers, we'll be getting the result in the decimal places. So when we divide two integers, we are not getting the result as an integer. So the closure property under division over integers is not applicable. Let's take some other example. -5 divided by 2. So -5 divided 2.5 under decimal places. So when we divide two integers, we are not getting result as integer always. So in some cases we take the -3 divided by -1, we'll be getting rows 3. So only some of the cases we'll be getting the result as an integer, but closure property of integers under division over integers. So over integers it's not applicable because only for some numbers it's applicable. If it is applicable for only some numbers, we say that the closure property is not applicable over that particular numbers, that is integers. So here your closure property of division over integers is not applicable. So let's go to the next property, that is commutative property. So if you take that into integers, -3 divided by -2. So -2 divided by -3. So -3 divided by -2. -2 divided by -3. So we'll be getting 3 by 2 because -5 minus will be getting plus 3 by 2, and -5 minus will be 2 by 3. So it is also plus because minus divided by minus we get a plus symbol. So 3 by 2 is equals to 2 by 3. It's not possible. So closure commutative property under division over integers, it's not applicable. Similarly, we can say that its associative property also not applicable to the division. And let's see that division by 0. We take an integer and divide in 0, and it is not possible. So it is not possible to divide. So 2 divided by -2 divided by 0 is undefined. So -1 divided by 0 is also undefined. So because if you take any number and try to divide with 0, you will not be getting the result as 0. Let's try. 2 divided by 0. So when we see, if we take in any number, then here the quotient 1 to 0 is 0, but 2 will be remaining. If you take 0, 0 zeros are 0, and we'll be getting 2 as remainder, and 1, 0 and 2. And if you take any number that is 0 only, and we'll be getting the same result. And what is the dividend? The dividend, what is the number? Present, the same number we are getting. We are not getting the result as remainder 0. So it is not possible to divide. So because when we are trying to divide it, so we are getting infinitely many numbers as a divisible. So it's not possible to divide. That is the reason we call it as undefined division by 1. So when we take an integer and divide it by 1, we'll be getting the same result of what we have taken. This -2 divided by 1 is -2 only. So -3 divided by 1 is also -3. -4 divided by 1 is -4. And whatever an integer we take except 0 in the numerator, if you take any number, the denominator 1, so we'll be getting the same result. So the division by 1 is nothing but the same result except in the 0 in the numerator. So until now we have discussed about the property of integers under division. Exclusion property is not applicable over integers under division. Commutative property is also not applicable under division over integers, and associative property is also not applicable. And division by 0 is not possible, so we call it undefined. And division by 1 will be getting the same result except the numerator will take 0. So -2 divided by 1, if you take any integer, -2 divided by 1, so we'll get the same result. And except in the numerator except 0 has been taken, and the denominator 1 will try to divide with 1, will be getting the same result like minus 2 we have taken, and minus 3. The numerator we have taken minus 3, will be getting the same result of minus 3, the similar form, and whatever the number we take in the numerator, we will be getting the same result